gang, and welcome to week 2 of Code Club. This week, we're going to go over a lot of the basic blocks you can use to build out your code and an advanced topic called looping. Open up another browser window and log on to Scratch so that you can follow along. Have fun and let's start coding. As we discussed last week, in the code section, there's many different categories for the types of code you can do, and we're going to go over some of the main blocks in each of these categories. The first category, called motion, is what lets you move your sprite around on the screen. Motion blocks are only available for sprites. If you switch to a backdrop, you see there's nothing in the motion category. So you have to be in a sprite in order to use the motions. The two main type of motions you can do for a sprite are moving it or making it turn its direction. We're going to talk about moving the sprite first. As you can see by the sampling of blocks I have up on the screen here, there's a lot of different ways you can move your sprite. The easiest one, the one that we've used before, is called move steps, and you put a number in here, I put 100 in, and it'll make your sprite move by that many steps. While the move block is really easy to use, it isn't very powerful. You can only move one direction and only a certain number of steps at a time. So there are a lot of other ways to do it as well. Before I go into the other options for movement, I want to show you the Scratch coordinate system, which tells you where your sprite is on the screen at any time. If you notice, it looks kind of like a graph like you'd use in math class or something like that. And right in the center is 0, 0. So x is 0 and y is 0. As you move over to the right, x goes up. So x goes from 0 all the way up to 240 is the highest x you can have. And as you move to the left, x goes down. So x is minus 240 is the lowest x you can have. And similarly with y, if you go up, it goes up all the way to 180 and then down all the way to minus 180. So as you move around on the screen, the x and y coordinates change, and that's how from within our code we can change the coordinates of our sprite and have it move around the screen. Going back and looking at the blocks again, you can see we have one here called go to x, y. And I can type in numbers here. So let me just type in go to x 100, y 150. That should move it over this way a little bit and up this way because I put both positive numbers in. So if I run that, 150 is pretty close to the top 180, so it's starting to cut off Scratch Cat's head. And then if I were to do negative 20 and negative 5, that'll move it like over here a little bit. So go to XY lets you put in a specific set of coordinates and it goes to them. I'm going to change this back to 0, 0 real quick and move Scratch Cat to the middle of the screen. And that'll let me show you some of these change and set options. So change means just what you think it does. It says change x by 50. That means whatever x currently is, it's going to add 50 to it. So right now x is 0. If I click this one to run it, every time I click it, it adds 50 to x. And you can see here, it started at 0. I clicked it 4 times. It's up to 200. Same thing with y. Right now it says change y by 50. So if I double click, it moves it up. And now y is 50 because I only clicked it once. And you can do the same thing as you did with go-to, where you can put in, I can put negative 10 here, and it'll move it down by 10. I can do negative 50 here, and it'll move it back 50. And you can see down here the x and the y coordinates are changing every time I do that. The set x2 and set y2, on the other hand, work more like a go-to, but only for one of the coordinates. So if I set x to 100, it's going to move x exactly to the 100 spot and leave y all by itself. Similarly, if I move y to negative 100, 110, and move that one, it moves y down to 110 and x stayed at 100 because I didn't do anything to change it. So set x and set y are basically like go-tos for just one of the coordinates. This go-to random position one does exactly what you'd think it was. Every time it runs, it just moves Scratch Cat to a random x and y coordinate. If you watch down here, every time I have it run that code, it's moving the x and y to just random different places. If you notice next to where it says random position here, there's a little arrow you can click, and it drops down a menu that lets you choose mouse pointer. So now it says go to mouse pointer. And what that does is it makes your sprite try to go as close to the mouse pointer as it can get. So a real simple example here, if I have him go back to 0, 0 and then click go to mouse pointer, he jumps across the screen to try and get to where my mouse pointer is way over here. A better example though is if I put a forever around the go to mouse pointer and then put a when green flag clicked on there. Now if I click the green flag As I move my mouse around on the screen, the Scratch Cat follows it because every time I move, it's looping through that forever and saying go to mouse pointer, go to mouse pointer. So it's a way to get your sprite to follow your mouse around on the screen. The last two options we have down here for moving your sprite across the screen are called glides. And what glide does, instead of jumping your sprite across the screen like these do, set X to 100 makes him jump over to 100, it makes it kind of look like it's gracefully moving to that position over a period of time. I'll click the glide 5 seconds to random position just to show you what happens. It picks a random place and Scratch Cat moves along to it, and you can see the movement as it goes. And so that's what glide does. It lets you see the movement rather than having it be a real jumpy like this. The number of seconds you choose affects how fast Scratch Cat looks like he's going. So that was 5 seconds. Here's what happens if I do 1 second. He moves really fast. If I bump it up to 10 seconds, or 19 seconds, now he's moving really, really slow. So the number of seconds just tells you how fast he's going to go. And you have an option for, you can glide 19 seconds to a random position or to the mouse pointer just like with the go to, or you can have him go to an exact X and Y coordinate. So you can say glide 1 second to X0, Y0, and he'll go directly to those coordinates that you type in. The next thing I wanted to show you is how to set the direction for the move steps block. By default, when you use the move steps block, it always moves from the left to the right. So this moves for 100 steps from, it was at 0, 0 to 100, 0 because it's always moving from the left to the right. Now, one way you can change it is you can put in a negative number here. I can say move negative 100 steps, and it'll move back to 0, 0. But what if I didn't want my sprite to move left or right? This is where the direction property of your sprite comes in. And you see right now it says 90, and that means your sprite points to the right. If you click in there, this little graphic pops up, and you can drag this arrow around and see that it changes the direction of your sprite. So now, if I want him to go up here, I can set it to be, about 46 degrees for my direction, and we'll have him move 100 steps. And now he's moving up towards this direction, which is exactly what I want. And you can set that direction in code instead of having to use this little graphic. If I come over here, right now it says point in direction 90, I can have it point in direction minus 135, and that's pointing it down towards this direction. So now if I move 100 steps that way, I have to run that code first, you can see he changes around. And then I move 100 steps, he's moving down in this direction just like I wanted. And then I can change this again, and we'll have him point up in this direction. And now move him 100 steps that way. So changing the direction changes which way it moves when you do the move 100 steps. I'm going to pull Scratch Cat back towards the middle of the screen so you can see what's going on here. The other options we have are turn right a number of degrees or turn left a number of degrees. And what that does is, rather than pointing in a specific direction, it just adds or subtracts from the current direction. So right now our direction is minus 30. If we say turn right 15 degrees, that's going to add 15 degrees to our current direction. And you can see minus 30 plus 15 is minus 15. Minus 15 plus 15 is 0. And we can do that all the way around, until it gets back to 90. And then the same with turn left 15 degrees. It's going to turn left and subtract down to 75, 60, and you can do this all the way around in the circle. You can also change this number to be whatever you want. Even weird big numbers like 540 degrees, that just means 360 degrees. Is this full circle, so that just means it's going to count through that circle several times and point in the direction it would be after doing all that math. So the turn left and turn right lets you turn from your current direction a specific number of degrees. And the last thing I wanted to show you for turning the direction was point towards mouse pointer. And this works almost exactly like go to. So that's why I have it in a forever with a when flag clicked on it. When I click the flag, Scratch Cat points towards my mouse pointer. Now I'm going to stop this real quick, and I'm also going to add a go to mouse pointer. And this makes so when Scratch Cat is following you around, he's also pointing in the direction of your mouse pointer. So it's a little program to have Scratch Cat follow me around. There's a couple more options in the motion category. If you look down here, there's if on edge, bounce, and set rotation style. We'll talk about that stuff a little later. They're a little more advanced topics and harder to talk about until you know a couple of other things. So we'll talk about those in a couple weeks. Moving on to the looks category, the simplest blocks are say and think. And what those do is pop up a little dialog box above your sprite's head that make it look like it's thinking something because it's got the thought bubble above it, or it looks like it's saying something. And you can have it say whatever you want by changing the text in here. And you can either have it say it or think forever, or do it for just a set number of seconds. So you can say for 2 seconds or whatever, however many seconds you want, and then it goes away afterwards. So if you don't put a number of seconds, if you use this one, it's just going to stay there forever. If you use the one with the number of seconds, it'll go away after a while. We already talked about switching costumes last week, but if you remember, in your sprite, you can have a different number of costumes, and Scratch Cat is built in with 2 that make him look kind of like he's running. And in the looks category, there are blocks to make him change his costume. So right now it's on costume 1. If I say switch to costume 2 and run that, he switches to costume 2 and change it back to costume 1. So he just keeps switching back and forth. And then next costume just switches it to the next costume in the list. So if you have 50 costumes in here, it's going to loop through all 50 as you go through next costume. The next 2 blocks shown here, change size by and set size to, let you change the size of your sprite. So if I change size by 10, he's going to grow by 10 every time that runs. And you can even put a negative number in here, so I'll put negative 20. Now if I run this, he shrinks by 20 every time. Set size to a percentage, 100% is the normal size of the sprite. And if you set it to 100%, it's going to change it to the normal size. If you set it to something else, it'll be bigger or smaller depending on what you put in there. So, and an easy way, if you're playing around with the size, you want to get it back to normal, set size to 100%, that'll be the normal size for the sprite. Show and hide do exactly what you think they do. Show makes the sprite show up on the screen, hide hides it from the screen. So it's still in your list down here, but you can't see it anymore. Why would you want to do this? A good example would be if you wanted it to look like your sprite was coming in off the side of the screen or something like that. Initially, you'd want it hidden so that you can't see it, and then later on you would show it when it's coming in so that it looks like it's coming from off screen. The last blocks I wanted to show you in the looks category were the ones talking about layers, and they say go to back or front layer and then go forward or backward a layer. And what layers are is when you have multiple sprites on the screen, it tells you which sprite is on top of another sprite. So if you look now, I drag Scratch Cat over the jellyfish sprite, and Scratch Cat is over the jellyfish. If I say go to back layer, that pushes Scratch Cat all the way to the back and the jellyfish all the way to the front. So Scratch Cat now is in the back. And now if I change it to be front, it's going to pull Scratch Cat to the front. This go forward or backward a number of layers is because every sprite in your program gets its own layer number. Then nothing can share a layer. So right now Scratch Cat is 1, Jellyfish is 2, and this little Giggle Walk Girl is 3. And as you move stuff around, if you wanted, I move her over, now she's on the front. I can go back to my Scratch Cat code and say go forward 1 layer, and that's going to pull him on top of her. And then if you see, now I have Jellyfish on top, so now he's number 1, Scratch Cat's number 2, and the girl is number 3. If I go back to Scratch Cat and say go backwards 1 layer, he's now underneath the girl, and if I say go forward 2 layers, that'll bring him all the way to the front. So the layers are only when you have multiple sprites on the screen. It just tells you which sprite is showing in front of the other sprites, and each sprite gets its own layer number so you can move them forward and backward in relation to each other. The sounds category is pretty self-explanatory, just a couple of gotchas I wanted to show you. So if you remember, all your sprites and your stage have a sounds tab that you can click on, and this is how you add or edit the sounds that are associated with your sprite or your stage. I'm just going to add another surprise one here. So I have meow, chill, and then this new one called ship bell. I'm going to go back to the code tab here, and you can see there's several different ways that you can play your sound. The first one is called play sound until done. And what this does is it plays your sound and doesn't let any other code in that stack run until it's done. So if I do play sound meow until done, It plays meow and then moves scratch cat. Now meow is a really short sound, so it's hard to tell what's going on there, but if I change it to a longer one like this chill sound, you can see this takes 8 seconds for this chill sound to run, and my scratch cat is not doing anything until it's over. Start sound is different in that it'll start your sound up and then go and do the next set of code right away. So let's do this one instead and see what happens. So you see, the sound started playing and it moved 10 steps almost at the exact same time. If you have sounds running that you don't want, you can use the stop all sounds block and it will stop them from running anymore. You can also set the volume of your sounds by using the change volume or set volume blocks. Change volume and set volume work almost exactly like the change size and set size blocks for a sprite. So if I start playing a sound, I change volume by -10, it's going to turn it down. If I set my volume to 100%, it's going to move it back to the normal 100% volume. If you have it go, let's say I set my volume to 20%, you can change the volume by a positive number. So I'm going to change volume by 10, set it to 20, and this is going to turn it up, but you can't turn it up past 100% because that would break your speakers. The events category is used to detect when things happen in your program, and those things are called events. Events can be things like when the green flag is clicked or when this sprite is clicked. There's a couple different options here that we'll talk through. The when green flag clicked event is the scripts that run when somebody clicks the green flag to start your program. This is important because for a lot of your programs, a lot of your scripts, a lot of your sprites, when you click the green flag, that's what's going to kick off a bunch of stuff that makes your program run. We talked about in the previous video how a lot of times you're going to want to use the green flag click to set your program back to the beginning. So if you want, scratch cat to be in the middle, you might have a go to x0 y0 to make him go back to the middle of the screen. But anything you need to do to reset your program, usually you put right at the top of a when green flag clicked. For this example, I just have it going to a random position. So if I click the green flag, scratch cat goes to a random position, and every time I do it, he goes to a new random position. Another option you have is when key pressed. And if you drop the arrow down, you can see there's tons of different keys you can choose from in here. I'm just going to leave it as the space key. And what will happen is when I click the space bar, that makes scratch cat go back to 0, 0. And if I do it over and over again, you can see it doesn't move anymore. But if I were to click the green flag and have him move somewhere else and then hit spacebar again, he goes back to 0, 0. There's another event for when the sprite is clicked, and it does exactly what you think. When you click on the sprite, it does whatever the scripts are underneath of it. So for this, I have when this sprite click, glide 1 second to random position. If I click scratch cat, he glides over here. I click him again, he glides over here. And you can have any sort of script you have. I just have real simple ones set up to show you what happens when you use these particular events. The last event I want to show you for a sprite is when backdrop switches. And to do that real quick, I want to change my looks and get a switch backdrop to. So it says when backdrop switches to Beach Malibu, point direction -90. So right now my backdrop is backdrop 1. I'm going to change it to winter and run that script. And you can see scratch cat didn't do anything. Now I'm going to change it to switch to Beach Malibu and now run it. And you can see it switches to Beach Malibu and scratch cat turned to be -90 degrees. So when backdrop switches is all about when the backdrop changes here. An important thing to remember is that each sprite gets its own code. So if I go and add another random sprite here, let's add this apple. Now you can see there's no code in here, but there is still code in the scratch cat sprite. If I go back over to the apple and go to my events, I can add any of these events that I want. The other important thing to remember is that you can have multiple of the same type doing different things. So if I have a when space key pressed, I can add another one that's when up arrow pressed. Or I can even have two when this sprite clicked pressed, and I'll add a move 10 steps and a turn 15 degrees. Now when I click on the apple, every time he's moving 10 steps and rotating 15 degrees. There are some reasons you'd want to do this. There's some reasons not to do it. Usually it's better if you have something like this to have all of your scripts under one of the events. But there are some valid reasons to do it. So it's something where you play around with it, and if it isn't working right, maybe try it the other way. Also remember that the stage has its own code, and that means that sometimes the stage gets its own blocks to use. And in this case, rather than when sprite clicked, the stage has when stage clicked, switch, and I added a switch random backdrop block to it. So now, if I click the green flag, it's going to switch the backdrop to backdrop 1. Every time I click on the backdrop, it's going to switch to a different one. There's a couple other events listed here. When loudness is greater than something, and then when I receive message and broadcast message. We'll talk about broadcasting and receiving later in the course. When loudness is pretty self-explanatory. It's got to do with the volume of any sounds that might be happening, so you can play around with that and it should be pretty obvious. Moving on to the control category, there's a couple of blocks in here that we'll talk about this week, and a few that I'm going to defer to a future week so that we can talk about them more in depth. The top 3 blocks, wait, repeat, and forever, are the ones I want to talk about most this week. The wait block causes your script to stop running for the number of seconds that you set. So as an example, I have it set up so Scratchcat will move 50 steps, wait 1.5 seconds, and then move 50 more steps. Let's watch it run real quick. He moves, waits, and then moves again, just like you'd expect. So you can use this in your script when you want to slow things down or make it look like something is taking longer than it actually takes to run the script. There's a lot of uses for the wait. The repeat block and the forever block are examples of what's called looping in computer programming. And looping means to repeat the same section of code over and over again. So if you look, you can loop a certain number of times using the repeat with a number behind it, or you can repeat the same code with a loop forever using the forever block. I have an example of each here, but before I do that, I want to show you how they work. If you drag one out onto the screen, you can see it's got this little blank space in here. Any code you put into this blank space is what's going to be repeated over and over again. And you can put as much code as you want in here, and you can take as much code as you want out. So anything that's inside this block will run over and over again. Anything that's before it will not. This will just run once. This will run 10 times. And then this thing underneath of it will only run 1 time again. I'm going to move Scratchcat back to the middle of the screen and pointing in the right direction before I run my examples. So for this one I have it set to repeat 24. He's going to turn 15 degrees, wait 0.1 seconds, and then turn 15 degrees again, wait 0.1 seconds, and he's going to do that 24 times. And the reason it's 24, you'll see when it gets to the end here, is that makes him turn back pointing 90 degrees again. And that's because if you look at the circle, the full circle is 360. 360 divided by 15 is 24, so that's how I knew how to loop 24 times to get him to point in the same direction again. For the forever example, he's just going to keep spinning over and over again for the rest of time, or until I click the stop button. One other important thing about the forever loop is that because it's running forever, nothing after it can ever run. If you notice, I can click onto the bottom of repeat. I can add more blocks down here. I can't do that under a forever because this code would never run if it was attached here. If we look at the other items in the control category, there's if blocks, wait until blocks, repeat until, and blocks about when I start as a clone and create clone and delete clone. We're going to talk about all of those things in a future video because they're a little more advanced. The last control block I wanted to talk about though was the stop one. And you can see here I have a stop all as part of this when green flag clicked, but I also have 2 other when green flag clicked. So first of all, I'm going to run this code without having that attached. And I'll click the green flag, and you can see Scratchcat is kind of flipping all over the place. He moved 10 steps, and then he's turning 15 degrees and going to a random position over and over again. Let me move Scratchcat back to the middle, and I'm going to add a little wait right underneath my move 10 steps, and then add the stop underneath it. And what that should do is it'll move 10 steps, wait a second, and then stop all the scripts on the screen. So this section of script should stop these 2 scripts from running. So you can see it moved, it did all the craziness, and then it stopped all the scripts from running, and he's not moving around crazily anymore. If you drop this arrow down, you can see there's a couple other options in here, one for stopping this script and one for stopping other scripts. So let me change it to this script, and it's not a very good example to have it underneath here, but if I were to move it into here, what will happen is it'll turn 15 degrees, wait 1 second, and then stop this script from ever running again. And as you can tell, if I have it be on this script, there's not a way to add any more code underneath it. So let me run this real quick. And you can see he changed his direction by 15 degrees, waited a second, and then stopped this script from running, but he's still moving around at crazy random positions. The other option is to stop other scripts in the sprite. And what that means is this script will keep running, but the other scripts, these two, will stop. And again, this one's not a good example because it only moves 10 steps and doesn't loop, but this one will stop looping forever. So let me run this real quick and see what happens. So now you can see he's not moving to random positions anymore, but he is turning 15 degrees and waiting. Another thing to note is that every time he's also stopping all other scripts in the sprite, which right now, because we only have the when green flag clicked, that's not something that you would notice. But if we had something where he did something based off of clicking a key or something like that, it could potentially stop that sprite from running again. If you have your stop set to all, that's going to stop all the scripts and all the sprites and on the backdrop in your program. It's not just going to stop the ones for this sprite or just the ones in the backdrop. It'll stop all scripts for all sprites. So real quick, I'm going to add just a new random sprite here. It's this weird looking dude. And I'll have a repeat forever. And I'll have him turn 15 degrees. And let me add a when green flag clicked here. So now I still have this set to stop all after waiting 1 second here. So what should happen is the outfielder is going to start spinning and then he'll stop just like everything else stops. So you can see this stops everything in every sprite and on the backdrop. One last thing to note about the stop is that depending on which setting you have it on, you might be able to add more scripts below it. So because it's on stop all, because that stops all scripts on all sprites and on the backdrop, you can't add more below it. If you're just stopping this script, you also can't add more below it. But if you change it to stop other scripts and not this script specifically, that lets you go and add other code below it that would still run. The last group I want to show you this week is called variables. And variables are things that store information about your program. So a good example is if you're playing a game, you might have a score. The score that you currently have is something you would store in a variable. Other things could be if you ever play Minecraft, like the list of all the items that you have in Minecraft is a variable. How much health you have in Minecraft is a variable. So every computer program uses tons and tons of variables to make up all of the information that your code acts on. To create a variable, you go to the variables category and click Make a Variable. There's a few options in here. We're going to ignore them for now. We'll talk about them in a few weeks. All you need to know is to put a new variable name in. And it's important to make this something you're going to remember what it is. So if it's going to be your score for your game, you should call it score or something similar to that. If it's going to be how much health you have, you might want to call it health. So you make sure that the variable name is something that indicates what is being stored in it. So now you can see I added a new variable called score. I'm just going to add a couple more variables here so you can see some of the examples of what I'm talking about. So I'm going to add one called health and then I'll add another one called items. So now I have 4 variables: health, items, my variable, and score. This one I don't actually want. I'm just going to say delete the my variable variable. So now I only have 3: health, items, and score. If you notice, when you added the variables, they show up in the window over here and it shows you what the current state of each variable is. So my score is 0, my health is 0, my items are 0. If you don't want them to show up, you can unclick this button over here and that makes them go away. So if you only want your score to show, you can have it just show the score or just the health, whatever you want to do. And when they're on there, you can drag it around and have it show wherever. So if you wanted to have them all show across the bottom of the screen, you could do something like that. To put data into your variables, use the set variable and change variable blocks. And the difference is the set variable sets it to a specific thing. So if I say set health to 55, it's going to set it to 55. You can see it shows up in the window here as 55. If I say change health by 1, every time I click it, it's going to change it by adding 1. If I click set again, it's going to change it back directly to 55. You don't just have to store numbers in variables either. I can set this to be anything I want. So I'm going to set it to be my name, Mr. B, and when I run the code, it sets my health to be Mr. B. Now that doesn't make any sense for health, but there are other times when you might want to store something like a name or an address or something like that. Anything you can think of, you can store in a variable. An important thing to note though is that only works with set. You can set it to be text, but you can't change by text. That doesn't make any sense. You can't even type text into here. All you can type is numbers in. And if I were to run this, it would set it back to be 1, 2, 3, 4 every time it clicks, even though it's text, because it doesn't know how to add 1 to Mr. B. Remember when I said that you could show and hide the variable on the screen? Well, that's something you can also do through code. If you notice, there's show variable and hide variable. So if I change these both to show items, hide items. So now if I have it hide items with code, it goes away, and then if I have it show, it comes back. So there might be a point, you're having a game and you only want it to show the score when the score increases. You would have a show variable that shows it for 10 seconds and then has it go away with hide variable, something like that. So that's a little more advanced programming topic we'll talk about later, but that's what the show variable and hide variable blocks are for. When you want to use your variables, you drag these little rounded edge blocks into places that would accept them. And you can see as I drag over, some of these places light up and let me drag it into it. And usually the places that let you drag it into it are places that look like they have rounded edges as well. Several of the code categories have variables in them. So if you notice, in the motion category, there's an X position variable, a Y position variable, and a direction variable, which I'm actually using in this little program I wrote over here. In the looks, there's variables for what the current costume number or the current costume name. In the sounds, there's a variable for the current volume level. So lots of the different categories have variables. We're going to talk about the sensing category next week, and this one has tons of variables in it for lots of different things. For this program, I set up 3 variables called rotation, X position, Y position, and I use them to just store the current rotation, X position, and Y position of the Scratch Cat sprite, and it displays them on the screen. Later on in the script, I have him say his X and Y position for a couple of seconds just so you can see how to use variables a little bit. So I have him go to a random position, and then I set my X position, Y position, and rotation variables to be equal to the ones from the motion category that we looked at before that show the current X position, Y position, and direction. Then it does a forever loop, and it says the X position and Y position, moves to a new random spot, resets the variables. So you'll see Scratch Cat will move around on the screen and rotate, and then display his current X and Y position with a say, and then the rotation will show up just in this window here. He never says those. So let's run it real quick and see what happens. So he says his X and Y, rotates and moves, says his X and Y, rotates and moves, and he just keeps doing that. And you can see he's only saying his X and Y position, and then the rotation just shows up here in this part of the screen. If I wanted to, I could stop this real quick and have something to hide the variables for the X position and Y position. Because he's saying them, we don't really need to see them. So now let's see what happens when I run it like this. X position and Y position go away, and just the rotation shows, and he's saying his X position and Y position instead. You might have noticed there's another option in the variables category called make a list. This is something we're going to talk about in another couple of weeks. Don't worry about it right now. Alright, that's it for week 2. I hope you enjoyed it. Go out and do some coding on your own. Have fun, be creative, and we'll see you next week.